In this one, let's take a look at 3 examples of factoring using the difference of squares concept. So the first one is the simplest. It says simply n squared minus 81. So step 1, step 2. Step 2 would be to rewrite this so it clearly identifies a difference of 2 squares. N squared is already a square. The 81 is not a square. So you try to rewrite it so it shows a square. So specifically, that's 9 squared. And then you have the negative between them. So that's step 2, n squared minus 9 squared. Then after that, you plug it into the difference of squares pattern, which says you put parentheses in place, and then you put n, or whatever the variable happens to be, okay? Like p or d or x or y, here it's n. And then you do minus 9, and then you do n plus 9. So this is the simplest version here, n minus 9 times n plus 9. And remember, to check that this is correct, what you should do is work back towards the original expression. And to check, you work back using our good old friend, FOIL. So you should really do that on your own. I'm not going to show you. I'm assuming you know how to FOIL. So this way, at least you have a way of checking. Just FOIL out the factored expression. If it restores the original, which is n squared minus 81, then the factorization is correct. Next one here, 4x squared minus 9. Now this one requires a bit of bit more manipulation, because that 4 needs to be rewritten so it shows a square. And the 9 has to be rewritten so it shows a square. Right now they're not doing that. So say this is step 1. Step 2, I take my 4 and I write it as follows. I'm going to put brackets to indicate the step numbers. So step 2 will be 2 squared times x squared minus 3 squared. I'm carrying that step out. Once that's in place, then at step 3 here, I'm being very detailed. This is now 2x. That 2 in the exponent, that is on the 2 and on the x. That 2, where my fingers are pointing, you can just pull that out and place it outside here where I'm pointing right now. And put parentheses around the 2x, just the way you see it. And then you keep the 3 squared. Once you have it in this form, then you can plug it into the pattern. The pattern says whatever this is. So this is 2x minus whatever that is, 3. Multiply by whatever this is, which is again 2x, plus whatever that is. The opposite of it is 3. This is the factored form, 2x minus 3 times 2x plus 3. Again, do keep in mind that you want to check it. You take your factored form, and to get back to the original, you would apply our good old friend, FOIL, multiply it out, and this should take you from step 4 back to 1. If it doesn't do that, then the factorization is wrong. The last one requires a little more work still, because now we have a fraction, so we have 1 over 25, y squared minus 1. So if this is the first one, then step 2, this is 1/25. You need to rewrite that so that it shows a square. So I'm going to write the 25 on the bottom. I'm going to say it's 1 over 5 squared times y squared minus, and the 1 here, I'm going to write as 1 squared. Remember that is so because 1 times 1 is 1 squared, but it's also just 1. So don't forget that basic fact. So I end up with 1 over 5 squared times y squared minus 1. I'm being detailed. Then, again, because this 2 is present right here on the 5, and it's present up there, you can reverse that step by essentially writing a parentheses and putting 1/5 of y squared this way. How do I know that I can do that? Because think about this for a second. The way the laws of exponents work. If I take that 2, I would distribute the 2 over to the y and over to the 1/5 individually. And now to restore this expression from step 2. Then I'm going to put here minus 1 squared. Once I've done all of this preliminary work, I then factor. I put my parentheses. Whatever this is, I put in here. So 1/5 of y minus 1. And then 1/5 of y plus 1. Just like that. I've been somewhat detailed here. A lot of people, once they do this a few times, they just skip a step. The step they skip is the one that I'm calling step number 2. they're able usually to go from like step 1 to step 3. And that's fine if you can do that. It's awesome. Okay? Same thing back in the middle example, in the middle panel. I wrote 4x squared minus 9, and at step 2 I wrote 2 squared x squared minus 3 squared. Again, a lot of people can, in the middle example, skip from step 1 to step 3. If you can do that, that's awesome. Do it. Okay? And the first one, that's the simplest kind possible. And for all of these, to be sure that you've done the factorization correctly, there's one thing to be done, which is, for example, in the last example here, let me erase this stray stuff. You would take the solution or the answer from step 4, and you would go back to step 1, and you would do that using FOIL. So if you can FOIL out step 4, it should restore the expression in step 1. Now that we've done some concrete examples, I do want to take a very brief look at some of tiny amount of the theory. Why does this actually work? So you do that by looking at something that involves some basic letters. Take a look. Imagine you have ax minus b times ax plus b. If you FOIL this out, that's how it all works, right? You FOIL. So ax times ax will give you ax squared. You can put the ax right here, and then a square outside the parentheses. So I did ax times ax. Then I do ax times b. That's going to give me plus axb. Then I do negative b times ax. That's going to give me negative bax. Then I'm going to have negative b. Let me make sure, right? I've already done this one. So now I'm doing this one right here. FOIL. Negative b times b is going to give me negative b squared. So when I carry this out, observe that axb and negative bax, they appear to be different. Remember, they're not. They're the same things. You can write when you multiply. Ax and b are just numbers in the end. And it doesn't matter the order in which you multiply 3 numbers. So you can write axb or bax. It's the same quantity, which means you can cross it off. It cancels. And at the end, you have ax squared minus b squared. What is this telling us? That's telling us something important, that you can go either from where I'm pointing, using FOIL, to where I'm pointing now, or you can instead, using factoring, go from where I'm pointing back to the factored form, ax minus b times ax plus b. The steps are reversible, in other words. Just like addition is reversed through subtraction, division through multiplication, FOIL can be used to reverse factorization, essentially, okay? And that's it. Thanks so much for watching. Leave a like. I'll see you in another video.